Hey everyone, hope you're doing well today. In this video, I'm going to be going over some practice problems just dealing with some general percent understanding, percent applications, and percent proportions. So let's jump right into it. Just so you know, in these directions, I'm going to say to show your long division or multiplication standard algorithm for at least 3 problems. So 3 problems each is what we're looking for just to get a little bit of practice in. Totally, it's fine to use a calculator for other ones, but just a little bit of practice for both, okay? First set of directions here says, write each ratio as an exact percent, so no rounding. If we have 14 losses to 50 games, that's a ratio of 14 losses to 50 total games. If you want to write that in fraction form, you can write 14 to 50. And remember, there's a few different ways to do this, but if you want to get this to be a percent, we could easily make this per 100, and you could multiply these both by 2. That's going to be 28 per 100. And so the percent is going to be, I'll write that as 28%. So this first one, remember, if you can get the denominator to be 10, 100, or 1,000, it's a little bit easier to understand those percents. Now, if you wanted to show the long division for this one, what I would do if I were you is just keep in mind that if you divided these both by 2, which is their GCF, you're going to find out this is 7 to 25. And if you wanted to do the long division, I always recommend using that most simplified version. And then 25 won't go into 7, so you can add a decimal, 0. It does go in 2 times 25 is 50. You can subtract here, that's 20. Add a 0, bring it down. 25 times 8 is going to be 200. And then you get a remainder of 0. So this 28 hundredths, if you move it over twice to the right, then you do get the 28% that we were just talking about. Okay, that's number 1. Moving on to number 2. It says you receive a 17 out of 25 on an assignment. So that's a ratio of 17 to 25. And turns out you can make this one out of 102 if you would like by multiplying this by 4 and by 4. And it turns out that 17 times 4, I think, is 68 hundredths. So as a percent, now it's per 100, so it's going to be 68%. Again, if you wanted to show the long division, you could take 17 and divide it by 25. That will get you the decimal. This goes in 0 times. So we're going to say this is going to go 6 times 25 is 150. And the remainder here is going to be 20. You can add another 0 and bring it down. 25 times 8 is 200, just like we said earlier. And so the remainder is 0. So if you take this decimal of 68 hundredths and move it over 2 times, that's also 68%. Okay. For this next one, we have a ratio of 42 to 56 students. What we could do here is we can simplify this by their GCF and divide these both by 7. Helpful to know those multiplication facts, okay? If you do by 7, I think actually we could have done a bigger number, but I think 7 is the most common people will see. That's going to be 6 to 8. And you divide them both by 2, that's going to be 3 to 4. Okay, so if we have this ratio of 3 to 4, right, what you can do is take that 3 to 4 and multiply these both by 25. If you want to make it out of 100, and that's going to be 75 to 100, and that is per 100 now, so it's 75%. Again, you can do long division here if you want to do the 3 divided by 4. So you can go say that goes in 0 times, but then it goes into 30. 7 times 4 is going to be 28. That's going to be a 2. Add a 0, bring it down. That's a 5. That's going to be 20, and the remainder here is 0. So if you take this decimal of 75 hundredths and move it over twice, that is going to be that 75%. All right, so that's the first part here. Moving on. Write each ratio in exact alternate form. So in this case, we're given the fraction, so I'm just going to write 3/4. We already know that one. For the decimal, what we can do is a foolproof way is you can do long division. So I know we did this earlier actually a moment ago, but it goes in 0 times. That's going to be 7 times 4 is 28. That's 2, bring another 0 inside, and then that's 5. All right, so the decimal here is 0.75 or 75 hundredths. And if you want to make that a percent, we're going to multiply by 100 or move it to the right 2 times, and that is now percent, 75%. Okay. For number 5, we actually already have the decimal, so we're going to put 0.24 right here. That's what I would do first. And then to get a percent, just like we did earlier, I would move it to the right 2 times. So that's really saying this is 24% because it's per 100. If you read that decimal properly and say 24 hundredths, then as a fraction, it should just be 24 hundredths. And then you could talk about simplifying here. So we can see, what can we divide both of these numbers by? I think 4 would be a number we could use. Okay, and then so if we do that, we could get 6/25. So the fraction in most simplified form is 6/25. Again, for simplifying, if you're having a little bit of trouble remembering what to do, if you would like to, you can go ahead and use the ladder method that we've talked about and start with like a 2, then you get 12 and 50, and then you could go ahead and use a 2 again, you would get 6 and 25. And that's where really I'm coming up with that 4. That's the side here, okay? Now, if you prefer to use prime factorizations, you can make trees for each of these, and 24 is 2, 2, 2, and 3. And then 100 is really 2, 2, 5, and 5. And the reason why we like prime factorizations is you can just cross out their common prime numbers, and you're going to notice here that if you multiply 2 times 3, you're going to get 6, and then 5 times 5 is 25. So whichever way you like simplifying, go ahead and make sure you choose which one you like. Okay. Moving on to number 6 here, we have 85%, so that one's already given to us, so that's 85%. As a decimal, so just like we did earlier, we move to the right, we're going to divide this by 100 and move it to the left. So as a decimal, this is going to be 0.85, but if we read it properly, that's going to be 85 hundredths. So as a fraction, it's going to be 85 hundredths. I know they're both divisible by 5 because they end in 5 or 0. We know our divisibility rules. I think that's going to be 17/20. So the fraction here, 17/20ths, is the same ratio as 85%. Okay. Moving on to this next one, we have 5/6, so the fraction's already done for us. So that's 5/6. Now, 6 doesn't go into 100 easily, so what I'm going to do is I'm going to go with the long division here. And so we're going to go ahead and take that 5, and we're going to divide it by 6. It goes in 0 times, so hopefully this is getting a little bit more familiar. 8 times 6 is going to be 48, and the remainder here is 2. Add another 0 and bring it down. That's going to be 3 times. 3 times 6 is 18, where the remainder is 2. Now at this point, I'm going to suggest that you stop because these 2's repeat, right? So what does that mean? That means that this 3 is going to be going on forever and ever and ever. So what's this decimal? This is going to be 0.83 with a line over the 3 because the 3 repeats. Now as a percent, be careful here. If you move it over 2 times or multiply by 100 to make it a percent, the percent is going to be not just 83%, but 83.3 repeater percent. Okay, so keep in mind that if it doesn't repeat, then it would just be a 0 afterwards. But since that does have a bar, it does go on forever and ever and ever. And so you need to show that that does keep going in the decimal. Okay, let me just make this a little smaller so I have room for this next one. Okay, for number 8, we have this decimal of 2.64. So I'm going to go ahead and write that right over here. I think the percent's going to be easy to do first, for me at least. So I'm going to multiply by 100. And so as a percentage, this is going to be 264%. Remember, any decimal over 1 is over 100%. And if you read this decimal, this is 2 and 64 hundredths. So the fraction is going to be 2 and 64 hundredths. Okay, it's a mixed number. Now, in terms of simplifying this, I think 4 is their GCF, if I'm not mistaken. And if you divide these both by 4, you're going to get 2 and 16/25. Okay, I don't think you can simplify anymore, so I'm going to write 2 and 16/25. If you weren't sure about the division, just use a calculator, or you can use the ladder method, or you can use prime factorizations, but I'm not going to write out that each time. Okay. This next one, a little bit trickier. This is a very small percent. So if you see a percent sign, then we know this is 2/5%. Okay, so keep in mind this is a very small percent relatively, and it's smaller than 1%. So what do we have to do to make a percent not a percent, or to make it a decimal? Well, we have to slide the decimal over twice to the left. But what is this 2/5 as a decimal? Well, what you can do here is you can just multiply this by 2 and multiply this by 2. If you do that, this is the same thing as 4/10. And what is 4/10 as a decimal? Well, that's just 4/10. Okay. If you didn't know that you could do that, what you could also do is just do 2 divided by 5. And you're going to notice that it goes in 0 times, and this is a 4, and this is a 20. So you're going to get 0.4 either way. Now, I'm not saying that this is the decimal. What I'm saying, though, is that this is the same thing as 0.4%, right? We didn't do anything with the percent sign yet. So what if we want to make this not a percent? Well, to make this not a percent, we're going to have to divide it by, Now, what if we want to make it a decimal? We have to divide it by 100 and move the decimal twice to the left. So if we do that, the decimal is actually going to be 0.004. Okay, so just keep in mind, to be a decimal from a percent, we do need to slide the decimal twice to the left or divide it by 100 at some point. So if you want to turn that 2/5 into a decimal, that might make it easier. Now, if you read this decimal properly, this is 4 thousandths. So as a fraction, this is going to be 4 over 1,000. Okay, I think you can divide these both by 4, okay? And if you do that, we're going to get 1 over 250. So the fraction here is 1 250ths. And that should make sense because 1% is 1 out of 100. And if this is 2/5 of a percent or even smaller than that, then it should be 1 over something bigger than 100, like 250. All right, one last one here. We have 3.2%. Let me move up a little bit. So the percentage is 3.2%. And so what is that as a decimal? Well, we got to slide over twice to the left, divide by 100. If we do that, the decimal is going to be 0.032, okay? And if you read that properly, that's 32 thousandths. So we can say it's 32 over 1,000. And what can we simplify this by? I'm going to try 4 here. Might be able to go more, I'm not sure. That's just what comes off the top of my head. That's going to be 8 over, I think, 250. I think we could do maybe by 2 here. So I should have just gone by 8 in the beginning. So divide by 2, and that's going to be 4 over 125. I think that's it though. Yeah, 4 over 125. Now, how do I know it's not simplifiable anymore? Well, 4 is 2 times 2, right? And then 125 is 5 times 5 times 5. So they have nothing in common. So that's how you know you can't simplify anymore. Alrighty, let's check out number 11 now. Let's switch gears. For these types of problems, in this case, I'm being very specific and I'm saying find the percent. So that's pretty nice to be told that in the directions. You may not always be told that. And so you got to keep in mind and look for some key features here. So if you're looking for the percent, just keep in mind that we have this kind of like proportion that we should be always using. And it'd be a good idea to maybe write this down on your papers too. Another key thing you could say is if you look for these words is and of, that can be very helpful as well. Okay, so the is will be the part, the of is the whole, and the p is the percent. So let me go ahead and mark this up a little bit here. It says 60 is, so that's going to be the part, and it says of 75, and that's going to be the whole. And then what we have over here is the p value, I think, or the x, whatever you want to call it, that's going to be p. Okay, so if we go ahead and write our proportion here, I'm going to go ahead and write our 2 fraction bars. A and B are going to be 60 and 75. And then our P, well, actually, I'll go ahead and write in. We always have 100 on bottom somewhere. And then we have our P value, which we do not know. Okay, so you can figure out what 75 times what is 100, but I totally recommend trying to simplify a little bit here. So if you would like to on the side, or if you have a calculator, you can use the ladder method. I'll try to show that a little bit for practice. That's going to be 12 and 15 if I use 5. And if I use 3 here, that's going to be 4 and 5. So the GCF here is 15. So if I divide this by 15 and divide this by 15, then the new proportion I'm going to get here is going to be having the same 100 and the P over to the right side. But on the left side, we should have this 4 to 5. Okay, and we like that just because 5 times 20 is 100, so 4 times 20 is P. So the value here is P is equal to 80. So what's our conclusion? The question is 60 is what percent of 75? And we just found out that 60 is 80% of 75. That's what we just found out. If you want to check this on a calculator, you could also just do 60 divided by 75, and you should get 0.8 or 80%. Okay. Moving on, for B here, it says 36 is, that's going to be our part. It says of 30, that's going to be our whole. And again, we are looking for the percent. So it's another practice problem to make sure you understand what's going on here. And so we know we're going to have these fraction bars. We know 100 is going to go somewhere. We're looking for P, and we have A over B. So we're going to have 36 over 30. Now 30 times something equals 100. I think I'm going to try to simplify here. I think 6, most people hopefully would be able to see 6 is a factor of both of these. And if not, go ahead and just, use your calculator or write prime factorizations out. We have 100 here and we have P. And then on the left side, we're going to have 6 and we're going to have 5. Now, just like the last one, 5 times 20 does get you 100, and 6 times 20 does get you p. So p's value is going to be 120. So 36 out of 30, that means if it was on a test or a quiz, you got some extra credit. So that hopefully makes sense that 36 is more than 100%. It's 120% of 30. Hopefully that makes sense, just because you have more than the whole here. The part is bigger than the whole. All right, moving on. Let's try some different types of problems here. So in this case, we're saying find the part. Okay, let me see if we can identify why that makes sense here. The question is, what is, so we don't know that, so A is the missing thing. Of 60, we know what B is, and for P, we know that that is going to be the P value, 250. Okay, so go ahead and set up our percent proportions here. We know 100 is going to go on the bottom somewhere, and we know we have this A, we don't know what that is, and B is 60, and then P is going to be the percent, but actually we do know that it's going to be 250. Okay, the fraction we can simplify is on the right here. I think we can divide this by 10. I think that would be enough. I think you can divide further, but I don't think we need to. And let me show you why in just a moment. So we're going to get on the right side 10 and 25, and on the right side we're going to have this A and 60. And the reason why I'm not going to simplify it more is just because we know 10 times 6 is 60. So then 25 times 6 would be A. So we're going to find out here that A is equal to 150. Okay, so what did we just find out here? It says what is 250% of 60? And it turns out that 150 is 250% of 60. So again here, the part is bigger than the whole. So it makes sense that we have more than 100%. So if you have a percent bigger than 100, then the part must be bigger than the whole because it's an improper fraction. All right, for this next one, it's another practice problem on the similar one. So we're looking for A again, and we know B. So try to get used to that pattern when we see these types of wordings. And we're given the percent again. So go ahead and set up 2 fraction bars here, and we're going to go ahead and put 100 on the bottom. It does say 80%, so I'm going to put 80 on top of the percentage of 100, and then we don't know A, and we know B is 130. Okay, now just like the last one, I think we could just divide this by 10 and divide this by 10. If we do so, then we're going to get A, whoopsies, we're going to go ahead and get A. Let me go ahead and set this up so I don't have to keep changing. A over 130 is equal to 10, and then we're going to have, I think, 8 on top. Now, the reason why I'm stopping here, even though I could simplify more, is we could multiply this by 13, and we can multiply this by 13, and I think 8 times 13 is going to be 104, if I'm not mistaken, 104. And so what we found out here is we found out that 104 is 80% of 130. Okay, and we can check this, right? On the side here, if we take 104 and we divide that out of 130, the ratio should be 0.8 as a decimal, which is 80%. Okay, so hopefully that makes sense. I can start showing that on the left side just to see if that helps confirm or help you understand a little bit more too. Okay, let's try these different types of problems now. Let's try some different types of problems now. So for number 13, we're going to try to find the whole this time. So the whole is going to be the B value. Okay, and so let's see what we have in our problem. So we have 23 is, that's going to be the A. It says of what number, so that must be what we're looking for. That's the whole. And then the 25%, that's going to be P. So we know we're going to fill in some stuff here. And so we know we'll have 100 somewhere on the bottom. A is 23, and we're looking for B. And we know our P value is 25. Okay. Hopefully we know we can divide these both by 25. And if we do that, then the new simplified ratio on the right is going to be a 1:4 ratio. And then we have 23 to B. And the reason why this works out pretty well for us is 1 times 23 is 23. And then 4 times 23 will be what B is. So I think 4 times 23 is going to end up being 92, if I'm not mistaken, right? And then so we can say that 23 is 25% of 92, okay? And if you want to check that, you don't want to do long division, you could take this 23 and divide that by 92. You're going to see that it is exactly 0.25 or 25 hundredths or 25%. So feel free to use a calculator to double check yourself by doing that simple thing. For this next one, for B, it says 75 is, so that's the part, or A, it says of what number. So we're gonna go ahead and say that's gonna be B, and then this is gonna be our p-value, okay? I'm gonna set up a proportion here and put 100 on the bottom, and we have 20%, so that 20 is gonna go on top, and then we're gonna put our A over B, or 75 over B, okay? I think we can simplify this. I'm gonna divide this by 20 and 20. If we do that, then we're going to get 75. Let me go ahead and put these fraction bars in. If we do that, we're going to get 75 over B is going to equal 1 to 5. And then how does 1 become 75? Well, 1 times 75 is 75. And then 5 times 75, what is that, 350, 375, I believe? Let's just check that real quick. Whoopsies. 5 times 75, 375? Yeah, okay. So B is equal to 375. So we're saying 75 is 20% of 375. So imagine if there's 375 dogs and you've pet 20% of them, you pet 75. So let's check that. What's 75 out of 375? Well, it's 0.2, which is 20%, okay? All right, for number 14, where you have 30% of students, of the total students, we don't know what that is. At the Princeton 5K, pet Benny. If 60 students pet Benny, how many total students were at the Princeton 5K? So right away, this 30%, we hopefully know that's going to be P, okay? If 60 students pet Benny, keep in mind they didn't all pet Benny, so this is part of the students. And the question does say how many total, so that would be the whole, right? That's everybody. So if I set up a proportion here, this should work out pretty nicely. So we know 100 is gonna go somewhere on the bottom. The percentage we know is 30%. And we know A here is 60 students pet Benny. And then the question is how many total students were there? Now, I know I say usually simplify, but like in this case, just notice that like you don't have to, because this is really nice. 30 times 2 is 60. So then 100 times 2 would be B. And so we can say that B is equal to 200. As you can say, there were 200 total students. Okay? So I know you can simplify if you want to, but if you are pressed for time, just try to think about what makes sense. In this case, it doesn't make sense to have to simplify anymore if you can already go straight to finding the solution there, okay? Number 15, if Mr. Lee had an allergic reaction to 72 out of 90 apples, what percent of the apples did Mr. Lee not have an allergic reaction to? So when it says what percent, okay, what percent, that's gonna be P, we don't know what that is. And for the parts, well, it says 72 out of 90. So that's gonna be A and that's gonna be B. Now just also keep in mind that it does say which percent does Mr. Lee not allergic to. So that's an interesting point as well. If you wanna find what percent Mr. Lee is allergic to, what you're gonna do is set up this proportion here, because different people may go about this different ways. So you would have the unknown percentage here, and on the left side, we'd have 72 out of 90. If you solve this one, you will find out what Mr. Lee is allergic to. All right, that is allergic. But then you're gonna have to subtract it later on. Or you can go about doing it a different way and say, okay, well, if Mr. Lee was allergic to 72 of the apples, then what percent maybe was he not allergic to just right away? Well, 90 minus 72 is going to be 18. So if you do 18 out of 90, this will be not allergic to, not allergic. So you can choose which one you want to solve. I'm going to go ahead and just solve the one to the right, because that one will tell us the answer right away. Again, you're gonna have to subtract at some point, and I would just rather subtract here, but it's your preference. I think I can divide these both by 9. And if I do that, that's gonna be what, 2 over 10? Oh, actually we could divide it by 2. So I should have just divided by 18. So that's gonna be 1 over 5, right? Yeah, that's gonna be, let's see, we'll put the 1 over 5. You can check that on a calculator if you're not sure. That's gonna be just like that, okay? 5 times 20 is 100, and then so 1 times 20 is going to be the p. So we're going to find out here that p is equal to 20. So we're going to say he's not allergic to, so we're going to say, I'm not going to write the whole sentence, not allergic to 20% of the apples. I'm just going to write not allergic to 20% of them, okay? So turns out that if you take 72 and divide that by 90 to check on a calculator, that's 80%. So 80% of them I'd be allergic to. And if you do 18 out of the 90, that is 0.2 or 20%. So if I'm allergic to 80% of them and 20% of them, I'm not. In a 400-meter race, Mr. Lee gave up 15% of the way through because he can't swim. How far did Mr. Lee make it? Okay, so the question is, I didn't make the whole way, obviously. This is the whole race, but Mr. Lee, how far did he make it? That's part of the way, right? Not the whole way. So let's see. We have our proportion, that's 100. We know the P is 15%. The A value, we don't know, that's the part that I swam. And then 400 is the whole race. Now, can you simplify? Yes, but why wouldn't we here? Well, it turns out we can already get this in very nicely. We can multiply 4 times. And so 15 times 4 is going to be 60. So right away we can say A is going to be 60. We can say Mr. Lee made it 60 meters. That's as far as I went. That's probably further than I can actually go. Alrighty, number 17. You walk into Target and you find a bike that you want to purchase. The original price is $400. You have a 30% off coupon and will have to pay 7% sales tax in New Jersey. What's the discounted price of the bike with the coupon? So we're just looking for the cheaper price. We're going to not talk about tax just yet. And so keep this in mind here, ready? So the original price is $400. You would normally have to spend 100% or pay for 100% of the price, but you have a 30% off coupon, right? So we should take away that 30% and then multiply that by the price of it. So this is a nice way to solve these types of problems. So 100% minus 30% is 70%, so 70% of 400. And as a decimal, what's that? That's going to be 0.7 times 400. And you can use a calculator here. So we're going to take this 0.7 and multiply that by 400. And you're going to see that that is going to be 280. So what's a discounted price? The discounted price is going to be $280 when you have the coupon. Okay, so if you don't have to pay for 30% of it, you do have to pay for 70%, and that's what that is, $280. Okay. For this next part, we have to figure out how much we're paying in taxes. So this one's just asking about taxes, not about the total price here. So what we can do here is we can just find the tax is going to be 7%. So it's 7% of the $280, not of the original. It's always the cheaper price. And that's going to be, what's 7% as a decimal? That's going to be 0.07 multiplied by 280. And we can go ahead and use a calculator. So it's 0.07 times 280. And that's going to be 19.6. So it turns out that you would be spending $19.60 just in taxes for this bike. Okay. So finally, it says, what's the final price you will pay? Well, you have to pay for the 100% of the bike, which is $280 at this point, after the coupon, plus the $19.60 that you have to pay in tax on top of that. And then so just to show it on the side here, because you can have a calculator as well, 280 plus 19.6, you're going to see it's going to be $299.60. So that would be the total that you would pay for this bike. I know it was originally $400, but you got a 30% off coupon, so we had to find that out. It's $280, and then we had to find 7% of that to figure out the taxes, and then add that on. And so this would be the final price you would pay. All right, moving on. You go out to eat with 4 of your friends at Nomad Pizza. That's irrelevant right now. We'll save that for the end. The total bill is $85.68. You all want to leave a 20% tip. That's collectively, not each person. And you have to pay 7% sales tax in New Jersey. So how much will the waiter or waitress receive? Now, we're leaving a 20% tip, so that's going to be 20% of the 85.68. And as a decimal, it's going to be 0.2 multiplied by 85.68. And so let's see, that's 0.2 multiplied by 85.68. And we have to do a little bit of rounding here, so let's actually make this an approximation. And so it's going to round to $17.14. That's 6 bumps to 3 up. So we're going to say here is the waiter or waitress is going to receive $17.14. Okay. For this next part, it says to the nearest penny, how much tax we have to pay. So tax is going to be 7%. So it's 7% of this 85.68. Remember, of means multiplication. 7% is 0.07 multiplied by 85.68. I'm assuming we're going to have to round a little bit here. So 0.07 or 7% multiplied by 85.68. That looks like it's going to be, that 7's going to bump the 9 up, and the 9's going to bump that 9 up, and it's going to bump up the 5 to a 6. So it turns out that this the amount of tax here is going to be $6. Okay. For this third part, to the nearest penny, what's the total amount you and your friends have to pay? Well, for this part, I think we already did the other parts. So what you can do here is one of two things. First, you can take, since we know all the parts, we could take 85.68 and then add on the 17.14 we found out, and then add on the $6. That's one way to do it. So I'm going to go ahead and do that over here. We'll take 85.68 plus 17.14 plus $6. And you're going to see that that's going to be $108.82. Okay, and that's because we knew all the parts because we already did it in the first couple parts. Now, what if we didn't know those and you just wanted to do it from the beginning? Just keep in mind that you would pay for 100% of everything, the food, plus 20% for the tip and plus 7% for taxes. And you could just multiply that by 85.68. And so, if you add up all those percentages, that would just be 1.27 as a decimal multiplied by 85.68. And so if you take 1.27 and multiply that by 85.68, you're going to notice it comes out pretty close here. It's going to be this 108.81. And the reason why it's pretty close is just because we did some rounding earlier. So if you got either one of these answers, I would accept that just because it just depends on how you're rounding and when you're rounding. So this is close enough in terms of depending on the method you use. So if you use the first method and you added them all up, you should get 108.82 and your work should support that. And if you use the second method, then I should be able to see that on your paper as well and confirm that you should be 1 penny less here. For this last part, if you did the first one, you should take this 108. Again, it's you and 4 friends, so there's 5 of you. I take this 108.82 and divide it by 5. So again, 108.82 divided by 5. We should do some rounding here. If you did that first method, you should get 21.76 a person. Okay, and if you use the other one, that would be what, that would be 108.81 divided by 5. Let's see if there's any difference here. 108.81 divided by 5, 21.76. Nope, same thing here. So per person, it's going to be the same. Depends on how much rounding was being done. So 21.76. Okay, either way, you're going to get the same answer for part D. All right, moving on to number 19. All right, so you originally would pay 100% of this item, but you have 60% off, all right? And you're gonna take that of the $54, which is the price of this thing. So you do have to pay for 40% of it. So I'm just going about this the most efficient way. You can find 60% off, then subtract it, but just keep in mind you are paying for 40% of it. And so 40% as a decimal is 0.4 multiplied by 54. And so if we find 0.4 times 54, this is going to be $21.60. All right, so this answer here, or this what we just found here, this is just going to be what we are. So this number we just got over here, this is the sale price. So after the discount, this is what it's going to be. Okay. Now what we're going to do with the sale price is we're going to have to pay 100% of this, But we're also gonna have to pay 7% on top of that because of taxes, right? So we're gonna take 100% plus 7% and multiply that by the 2160 or this sale price. The government's gonna get 7% of this number here. And so this is gonna be 107% multiplied by the 2160. And as a decimal, that's 1.07 times 21.6. And so let's go ahead and do that over here. 1.07 times 21.6. And looks like we're gonna do a little bit of rounding here. So that's gonna be about $23.11. Okay, so this is going to be with tax. And this is gonna be what you pay at the end of the day, okay? Just keep in mind, like if you wanted to find 7% of it, that's perfectly fine. Then you could add that on. This is just going to save a little bit of work and hopefully help you solve these types of problems just a little bit faster. Okay. Final regular question for this, number 20. You go out to eat with two of your friends, so there's 3 people total. The bill comes out to $83.25. You want to leave a 25% tip and a 7% sales tax. How much will each of you pay? All right. So it's not asking about any parts, so the most efficient way to maybe go about this is realizing you do have to pay for 100% of the food, but you're also going to leave a 25% tip, and you're also going to leave 7% for tax. And that's all going to be of this $83.25. And eventually we're going to divide this whole thing by 3 because you're splitting it 3 ways, okay? If you add up all the percentages together, right, if you add up all of these numbers together here, that's going to be 132% of this 83.25, and we're going to divide that by 3. Now, as a decimal, 132% is just 1.32, so we're going to say 1.32 multiplied by 83.25, and then we're going to divide that by 3. Now, let's figure out what this number is first. I'm going to take this 1.32, I'm going to multiply that by 83.25. And it looks like we have a value of 109.89. That's the total bill. And we're going to split that 3 ways now. So we're going to take that answer and divide it by 3. So it turns out that this final number is going to be $36.63 per person. All right, cool. So that would be how much each person would pay here, chipping in equally for that total bill at Thai Village. All right, let's take a look at a few challenge problems here. So this first one for 21, we're dealing with some compound interest. So you put $4,800 into a savings account that pays a 3.2% interest rate, compounded monthly. After 10 years, determine the account balance to the nearest penny. Okay. So if you're not sure about what the formula is, you can either look it up online or it's going to be here. So the account balance is equal to what you initially put in, which is P, and multiplied by 1 or 100%, plus the interest rate divided by N, or how many times it's compounded per year, raised up to the NT power. Okay, so let's figure out if we can define each of these variables and then go about substituting them in. So first thing, it says the total account balance. That's what we're looking for. The account balance, that's going to be this right here. If we want to know what P is going to be how much money you're putting in. So that's going to be the 4,800. Okay. The interest rate, or R, is going to be 3.2%, but we like using the decimal version when we're doing problems or computing. And then we need to know N. N is how many times a year you're getting your interest. So that's going to be 12 because they do say it's monthly over here. And the last thing is they do say 10 years. So that means T must be equal to 10. So are these problems difficult? Not really. It's just a kind of scary looking formula, but you need to be able to plug everything in the right spots. So we're going to look for A here, and let's just substitute in. So we have 4,800 multiplied by 1 plus, and we have 0.032 for R over N, which is 12. And we're going to raise that to the NT power, or 12 times 10 power. All right, so using our calculator over here to the left here, we can simplify this down a little bit and say this is 4,800. And let's figure out what this 1 plus the 0.032 divided by 12 is. Okay, so it looks like it's going to be 1.0026 repeater raised to the, and then what's 12 times 10? That's 120. So that's going to be our exponential, that's going to be our exponent here. And so we're going to take this answer and we're going to raise it to what power? We're going to raise it to the 120 power. And then take that answer and multiply it by the 4,800. So we're gonna have to do a little bit of rounding here, but it turns out we're going to be getting $6,607.40. So I'm gonna go ahead and write that over here. It's gonna be $6,607.40. That's gonna be how much money this account has in 10 years if you just let it sit there and collect interest. All right, let's check out number 22. Mr. Lee purchased 47 shares of a stock at the price of $38.55. Then he sold it for $64.28. Determine how much Mr. Lee made in profit after paying a 25% income tax on the money he made. To the nearest whole percent, how much did the stock increase or decrease? Okay, so when you make money, you typically are going to be paying some sort of income tax on it. We're saying 25% here. And so let's see here. How we're going to set this up? Well, the final price was $64.28, and the original price was $38.55. So to see how much money he made from one stock, or for one per one, the unit price or unit difference, and then multiply that by 47 to see the total amount that was profited. So let's see how much the profit was before paying tax. Okay, so if we go ahead and take the 64.28 and then take away the 38.55, that is going to be 25.73, and we're going to multiply that by 47. So I'm going to take that and multiply it by 47 because that was just what the profit was for one share. And so it looks like this is going to be $1,209.31. So this number right here is going to be the profit after buying and selling. So I bought, 47 of them at $38.55, and then each one went up to $64.28. We found out there's a profit of $25.73 for one of them, but we had 47 of them, so that's over $1,000 there in profit. Okay. Now, I don't get to keep all of that, right? The government wants their part of that, or I have to pay this income tax. So I have to pay 25% of that. So I don't get to keep all of that. So what's going to happen here is I normally would keep 100% initially, but then they take their 25%, right? And we're going to take that of this 1,209.31. And so what do I get to keep? I get to keep 75% of it, of that 1,209.31. 75% as a decimal is 0.75 times the 1,209.31. And so if we check that out, we can go ahead and take 0.75 and multiply by 1,209.31. And this comes out to approximately 906.98. So this is going to be $906.98 profit. That's after paying taxes, is what I actually get to take home and spend and have for myself. Okay. The other question here, though, is it's asking to the nearest whole percent. So we'll do some rounding. How much did the stock increase or decrease? Well, the stock definitely increased, so that's what we're saying. It went up in price. And so if you ever need to find percent change, the way you do that is you just take the difference of the absolute value of the difference of the prices, but you can always just take the bigger one minus the smaller one. In this case, it's always going to be the final minus the original, and then you're going to divide that by the original. So what was it before? This will always tell you what your percent increase or decrease is. Now, if the top becomes negative, then you put it in absolute values. But if you go ahead and see the difference, we already knew the difference was this 25.73. So if you take the difference or the change and divide it by the original, the question is what percent did it change by? So if you take the ratio of that, you will find the percent change per 100. So 25.73 divided by 38.55. That's looks like a decimal version is over there of 0.667. So as a percent, if we slide it over twice to the right, that's going to be 66.7%, but it does say to the nearest whole percent, right? So I think we're going to say 67% increase, and that's a lot. Okay, so it went up 67%, and that's why we made money, not lost money. It is possible to lose money. All right, let's do one final problem here. A rectangular photograph with a length of 8 inches and a width of 10 inches is hanging on the wall. If the dimensions are shrunk by 75% of a new size for a photo album, then increased by 75% to be hung up, determine the percent change of the area of the original photograph to the final photograph. Okay, so let's see what the original photograph here is going to be. 8 by 10, okay. And then, so it says, what's the percent change of the area of the original? Okay, so what's the area of this one? I think we can do that really quickly. The area of this one is going to be 80 square inches. All right, so we know the area of the original one, and it turns out they were shrunk by 75%. So if it was shrunk by 75%, that means that we're keeping 25% of it. So we need to shrink this thing. Let me write shrink. And so this is getting smaller, but the question is like, how much smaller is it, right? And so if we shrink it by 75%, what does that mean? That means we're keeping 25% of it. So we have to take 0.25 of 8, and I think that's going to be 2 because that's just 1/4. But we also have to take 25% of 10, and that's going to be 2.5, right? So the new dimensions here are going to be 2 by 2.5. So each of the dimensions shrunk by 75%, or we are keeping 25% of it. So that's that's the first part where we shrunk it down. We're going to now grow it or enlarge it and make it bigger now. So they're saying let's increase it by 75%. So it's going to get larger. Okay. If we make this larger rectangle here, let's say it's increasing by 75%. So that's going to be 75% on top of this measurement. So right now, that's going to be 1.75 times 2. So we're going to multiply 1.75 times 2. It's now going to be 3.5. That's for this one right over here. And we're also enlarging the other width or dimension by 75%. So that's going to be 1.75 times 2.5. So 1.75 times 2.5. And that's going to be 4.375, or 4 3/8. So 4.375. So if you wanted to find the area of each of these along the way, over here, this should be 5 inches squared if you multiply those together. And if you take the 3.5 and multiply that by 4.375, this area here would be 15.3125 inches squared. Okay, so just keep in mind that when you are shrinking here, what's really going on is that's 100% minus the 75%. We're losing 75% of it here, but here we are growing it, but it's 100% plus 75%, right? But the starting amount is different. So the starting amount in the beginning was the original, and then when we grew it, we were growing it from the smaller version. So we want to make sure we understand that it's not going to be the same as the original size, okay? The question does then say here, we are going to determine the percent change of the area of the original photograph to the final photograph. Okay, so what did we say a little bit earlier about percent change? Well, we need to find out the difference between like the final and the original. So sometimes that's going to be negative. And so we have 80 was the original minus 15.3125 divided by the original, which was 80. So let's go ahead and take 80 and then take away this 15.3125. That's going to be 64.6875. That's how much it changed, divided by the original. So if we take that answer and then divide it by 80, it looks like we have this decimal here. So the percent change here, I'm going to round this to the nearest whole percent just for the sake of keeping it pretty straightforward. This is going to be about 81% decrease. So the area got quite a bit smaller. All right, so that just about wraps up these 23 problems on some percent proportions, percent applications, and just general percent understanding. And as always, don't forget to simplify.